Hey guys, so I'm gonna make just a quick video for you to talk to you a little bit about volume of a prism or pyramids. Um, I may get interrupted by some kids running around, but I have to pause it and that's okay. So the first thing you need to understand is what is a prism versus what is a pyramid. This formula here is for a prism and this one is for a pyramid, and I think that isn't too difficult of a concept. Prisms are typically shapes that have the same shape as its bases. So what I mean by that is you got something that's like maybe like a triangle on one end, and then you stretch that triangle and it's still a triangle on the other end. Okay, so these triangles are considered the bases. And I know bases can be confusing because there's lots of types of bases. Capital B is what we're talking about for the base. It's a shape. This is a shape. And that's a big thing for you to understand, that this is a shape. Okay. If we're talking about a pyramid, that capital B is whatever we start with, but then it gets stretched to a point instead of to another shape. So I know these pictures aren't the best, but hopefully they'll work out for you. Another example is, say we have a cylinder, which is a circle on one end, and it's stretched to another circle on the other end. Okay, something like that. Or maybe we got a trapezoid, and it's stretched to another trapezoid. Okay, so it looks something like this. This is a prism. You can imagine trapezoid in the back there. So a base would be this trapezoid here in the front, this thing, and then there's another trapezoid in the back. Both of those are bases. Now you only need one of them to find the area of that. That would be this thing. And then the height is the stretched length, how far it is between those two bases. So really when we're talking about capital B, we're talking about the area of some shape. And then this is the height is the length between the two bases. So the base doesn't always have to be on the bottom. So like I drew this picture, or like how I drew that picture, the base is not necessarily on the bottom. Okay, but here I drew this picture, the base is on the bottom of that shape. I know these aren't the best pictures, but hopefully you get some kind of idea of what I'm talking about. So I got some more pictures here to show you. Maybe that'll help you understand. So first, is this a prism or is this a pyramid? Hopefully you can look at this and understand that this is a pyramid. How about this one? Prism. This one. It's a prism. This is a prism. Actually, this is a cylinder, which same formula as a prism. Prism again. Pyramids. This is like a pyramid's formula. It's a cone, but same formula. Right here we got another cone, which is the same formula as a pyramid. So if you just narrow it down to pyramids or prisms, the only difference between cylinders and cones is that the bases are circles. Okay, so this is another prism. Prism because the base here is that triangle out in front. I'll highlight it for you. This triangle right here is the base, and it has that same base in the back. The length that is in between those two bases is considered the height, even though it's sideways. It's the height right there. That's the height. Do another one. Pyramid. Okay, so let's go back to some prisms. Prisms tend to cause the most problems. Once again, there is your base. Here's the same base. The height is the length between them. Okay, let's do some more. Here is a base right here. You get the same base down here. You have to imagine it's back there. And then the height is the length between them. Remember, base and height are always perpendicular, and that still holds for this thing. We're talking about area of bases. So the capital B is actually the area of a base. Okay, so this thing is the area of the base. So we're talking about how much is this area of this triangle. Okay, how much is the area of this triangle? Pick one of them, it doesn't matter which one, because they're the same shape. Okay, so we'll do a couple of these, but that's the main thing, is to make sure you understand the difference between prism and pyramid. You need capital B is the area of the base, and the H is the distance between those bases. Over here, it's the distance that's perpendicular from the base to the point at the top. Okay, and that has to be perpendicular. So once again, we don't want like a pyramid that's like this and it goes down to a point. We want the height to be this perpendicularly straight up and down. So it's right here. And usually they put a little right angle symbol here to let you know that that's perpendicular to the base. You don't want to use this length as the height. That's not perpendicular. I've told you a long time ago, bases and heights are always perpendicular. Okay, so don't use a slanted length as the base. I'm sorry, as the height. All right, let's try just a couple of these because I don't want to take a very long time in this video. So this is a prism, a rectangular prism. It's named for its base, and the base is a rectangle. So if we were to highlight the base, either this base or the imaginary one back here, down here, this base, it should be the same thing. You need to find capital B and times it by the height. Capital B is the area of the base. So the area of, in this case, a rectangle. Okay. So how do you find the area of the rectangle? It's got its own base and height. So that's where it get kind of confusing, but it's little b times h. Little b is the base of that rectangle and the height of that rectangle. So it has a base and it has a height right here. Its base and its height, which are perpendicular to each other. If we can look at this from the top view, you'd see that this would be a right angle right here. Okay, so this is 10, which is also 10, and that means the base is 10 times the height of 40. So sometimes I like to draw it separately. You got a base of 10 and a height of 4, and that means this has an area of 40. This has a capital B of 40. This number right here is 40. So 40 is capital B. Times that by the height of the whole thing, which is 20, and you got your answer. Okay, this should be 800, I believe. Volume is always measured in units cubed or cubic units, so we put centimeters to the third power. Hopefully that makes a little bit of sense. Let's try one more. It's going to be a little bit more confusing, but once again, let me clear all the stuff off for you. You want to find the capital B, which is area of the base. Area of the base, not just base, but area of the base. So it's area of some shape, which is this thing, because it's the same on top and bottom. Find the area of that triangle, and then times it by the height, which is perpendicular to it right here, straight up and down. Okay, so it helps for me if I write down what is the shape that I'm trying to find the area. In this case, it's the area of a triangle. Use a triangle symbol, which has a formula of 1/2 b times h. This b is talking about the base of the triangle and the height of the triangle. So we're going to find the area of the triangle first. And these two numbers should be perpendicular to each other. It's a little tricky. So I'm looking for this number and this number. Don't use 15. You want the base and height to be perpendicular, little right angle symbol. That's what you're looking for. So in order to figure out this number, you're going to have to use Pythagorean theorem. Okay, so I'm looking for the area of this triangle where this is 15 and this is 9, and I need to figure out this number right here. Now I'm not going to go through all the steps to do this, but you should be able to use Pythagorean theorem and figure out this is 12. Okay, so one of those numbers is 9, the other one is 12. Base and height, they're perpendicular to each other. Base, height, it's base and height of the triangle. Okay, and you would take 1/2 times 9 times 12, and eventually you're going to get, this is 6 times 9, that would be 54. Okay, so this is 54. This number right here is 54. So 54 times the actual height of the whole thing. We're talking about volume now. We're talking about the whole shape. That's the height. That's volume. This h is for the height of the whole prism, which is 7. And I don't know what 54 times 7 is, but whatever that is your answer. Okay, I guess I can figure it out real quick. If this will open up. Okay, 54 times 7 makes 378. And once again, units are centimeters to the third power for volume. Okay, so that's a couple prisms for you. Pyramids are done the same way. The only difference is that you got to use a third. And I had a little video I would show you. I mean, if I had time, I would make a little video showing you how I had these shapes at school where I could show you this pyramid and I fill it up with water 3 times and it would fill up something of the same, a prism of the same base and the same height. You could take this pyramid and fill it up 3 times and fill up the prism of the same base and same height. I know that might be confusing. Maybe in a separate day I'll make a video about that. Okay, but the point is here we're doing 1/3 capital B times H. Capital B, once again, is the area of the base. So I'm looking for the area of this triangle. Okay, so I need to find the area of a triangle right here. So we got to go back to area, which is 1/2 little b times H. Little b is the base of the triangle and the height of the triangle. And those are perpendicular to each other, this one and this one. Oh, and once again, this one's not given to you. But it is a right triangle. You can use Pythagorean theorem. You got a 17 back here. You got an 8. And so what you should be doing is eventually taking this square, 17, which I think is 289, minus this square is 64. And you figure out this square and then take the square root of that. I'm not going to go through Pythagorean theorem too much, but eventually you should get your answer of 15. Okay, so if we continue with finding the area of the triangle, it's 1/2, and the base of the triangle, which is one of these perpendicular sides, maybe 6, I'm sorry, maybe 8, this is 8, and the other perpendicular, the other part that makes perpendiculars, 15, so this is 8 times 15, and then we're going to do, once we figure out all that, we have to do the 1/3, and we have to do this height, which is the height of the entire pyramid, which is this 21. Notice how this 21 right here is perpendicular. I know it's got a lot of writing there, but it's perpendicular to, let me erase some of that. See how this height is perpendicular. It's got a little right angle symbol. Perpendicular to the base. That means that's going to end up going right here, 21. So let's focus on the area of the triangle. 1/2 times little b 8 and h 15. So that's 4 times 15, which is 60. So 1/3 times 60 times 21 would mean 1/3 of 60 is 20, and 20 times 21, I'm not exactly sure what that's, 420, I think. 20 times 21, 420. Okay, so the answer is 420. We're talking about yards to the 3rd power. Okay, got one more for you here, and we'll probably call it a day. All right, so once again, you want to find the volume of a pyramid, which has a formula of, which has a formula of 1/3 capital B times H. So 1/3, capital B is the area of a, in this case, it's the area of a rectangle. And then we're going to times it by H, which is the height of the whole thing, this thing right here, 20. Okay, so I'm going to try to figure out the area of the rectangle right here, this area of the rectangle, which is pretty easy. Its base and its height, they have to be perpendicular to each other. So one of those lengths is 15, the other one is 5. 15 times 5 is the area of the rectangle. And 15 times 5, I believe, is 75. So this is 75 meters squared. We're going to take this 75. Sorry about this words underneath this stuff. 75 times 1/3 and times the height of the whole pyramid, which is 20, right here. Okay, so 1/3 times 75 times 20. And I don't know the answer off the top of my head for all that. I could punch in a calculator and figure it out. You could do 75 times 20 and divide by 3. It's the same as multiplying by 1/3. I know that 1/3 of 75, I believe, is 25. 25 times 20 is going to be, let's see, I think that's 500. But we'll do it a couple ways. 75 times 20 is one answer. Now I'm going to divide that by 3. It's 500. Sorry about the sloppiness. Pin's not working too well. Anyway, that should be 500. 500, our units are centimeters, so we're going to say 500 centimeters cubed. Okay, hopefully this helps a little bit. I don't know if it will. I'll try to make a separate video on spheres. But main thing, once again, is find the area of the base first. And you got to know what shape that base is. For prisms, it gets a little bit more complicated, but just look for that shape that's at the same on both ends, okay? So rectangles on this end and that end. It's whatever shape got stretched is a way to look at it. So I look at like a sphere. I take this thing and I stretch it that way, and it still makes another circle on the other end. I said sphere, I meant circle. Or I can look at this triangle right here. Take this triangle, and it gets stretched in all directions this way, or all 3 corners get stretched that way, and it makes another triangle in the back. So if it can take the shape and you stretch it out, then that makes it a prism. If all the corners go to a point like this, all 3 corners here get stretched out to one single point, then that's obviously going to be a pyramid. Okay, just make sure you're using the correct formula and recognizing that capital B here is the area of a base. All right, hopefully that helps some.